All right, without further ado, let's dive in. So today we're going to be talking about authentication. So Andrew and I will be talking about it conceptually for maybe like 45 minutes or so, and then we'll do a little bit of workshop. Okay, so as you might have guessed, one thing that we're missing in Catholic is user identity. So, I need to stay over here. Okay. So we need to know who we are in the top right corner when we're looking at Catholic, and we also need to know who we are when we're posting things so that we can associate the right name to the post. And so, question for you guys, how do we prove our identity to a website? Anyone? Anyone? Yes, in the back. Yes, exactly. So the most basic way of doing this is using a username and password. So I have a username which identifies me, and a password which is something secret that only I know. So if I prove to the website that I know Abby's password, then I prove to the website that I am Abby. Okay, and what this looks like on a sort of more low level is I send a post request to some kind of API endpoint on my backend server that says, hey, this is my username and this is my password. And then in order to check that this is correct, the backend server does a database query to check in the database, okay, look up the user with this email and see if she has password this. And then the database will respond back with, okay, yes, she's good. And then the server will respond back with, oh, you successfully logged in. Yeah. So in order to do that, in order to do a database query where we check if the username and password is logged in, then if the username and password combination is correct, that means that we need to store information about our user in our database. So we need to have an entry and with information about every single user, which we currently don't have yet in Catholic. And so this is one proposal for how we store information about users in our database. Open hands if you think this is good. Closed hands if you think this is insecure. Cool. Someone with a closed hand, why do you think it's bad? Okay, can I pick on you, Maynard?
It's like pretty easy accessible.
Exactly. So if you have developer access to the database, then you can literally just read off passwords. And if the database gets hacked and those passwords get leaked, then not only do the hackers have access to all of your users' login information, but since people frequently reuse passwords across multiple websites, you also have people's login information to probably a ton of different other websites as well, and the entire internet would just go down in flames. So enter hash functions. What a hash function does is it is a bunch of fancy math that takes in an input, which is a string, and then sends it through the fancy math and outputs something that looks like gibberish. And there are two important things about hash functions. One is that it's one way, so you can't reverse engineer a hash. You can't look at what comes out and tell anything about what came in. And then the other thing that's important about a hash function is that if you send in the same input string, you'll always get the same output string. And so what that means is that we can store our password hash in the database instead of just the password. And so when we create an account, we set up this thing in our database, we hash the password and store that. And then when we attempt to log in, we send in our attempted password and we hash that and see if the hash is the same as what's in the database. That way, we never store plain text passwords in our database. Open hands if you think this is secure now, closed hands if you think it might not be. Okay, I sense a lot of uncertainty and that is totally okay. This is actually not secure yet, and that is because there's something like this online where you have like the 10,000 most popular passwords and then their corresponding hash. So the MD5 is just one of the hash functions. And so if you store those hashes in your database and then your database gets leaked, then they can just go to a website like this, programmatically scan through all of those hashes and see if any of those match up to the ones from your database. And chances are a lot of them will. So the solution to this is something called hash salting, where we're not going to go into a ton of detail. You don't need to understand this fully, but you can just look it up if you're curious. It's cool. So basically we take a little string and we add it to our password and hash that, and then store both the salt and the hash in the database. And so when someone attempts to submit a password, we add the salt and hash it and check that that's the same, so that these hashes will never appear in those lists of like, oh, most common hashes. Okay, that was just a blaze through. But then it turns out that this also isn't entirely secure, because if someone's allowed to make a bunch of login requests to your endpoint like really quickly, then someone can just write a program that makes a bunch of requests and guessing passwords. And so that would be sad too. Bottom line is, storing passwords is really hard, so we are not going to do that. We're going to let Google do it for us. So instead of having the email and password button, we're just going to have on our website that nice little login with Google button. But then that poses an interesting question, because if I click on this button, oops, I always forget that this. All right, if I click on that login with Google button on Whimsical, it will direct me to a page like this. And you notice that this is a Google web page. This has nothing to do with Whimsical, because, I mean, it looks like a Google web page, but also you can see in the URL bar, the URL is just entirely Google. So the question is, if once we log in, how does Whimsical know that we successfully logged in with Google? Because it took us to a Google web page. Okay, so we're going to put a pin in that question and then come back to it in a little bit. We have another question, and that is, once we successfully log into our website, so Andrew logged into Piazza, and then we start clicking around and doing things, how do we stay logged in? And to explain why this is kind of like an issue, we need to understand what's going on under the hood here. This is an HTTP request, or like an overly simplified HTTP request. And we send that to our server, and we get back a response. And there might be multiple clients all interacting with the same server. But all the server's doing is listening for requests, it takes it in, and then it sends a response. And even though this is what's happening, there's multiple clients on distinct computers, distinct browsers, all talking to the same server, and they each have this like conversation going on. All the server sees is this. It just sees a sequence of requests. It doesn't know that one is coming from this computer, one is coming from the other computer. All it does is it sees the stream of requests, and it takes one in, does its computation, whatever, and then sends back a response. And so the question is, if Andrew made this initial request to /API/login, oh wait, I can use my laser pointer. So fancy. If Andrew made this initial request to log in, how does the server know that this is also Andrew? So it can give it back a response like in accordance with him being logged in, but this is not Andrew. Okay, so I have a proposal. Okay, question is, how do we prove we logged in when we're making requests in the future? So my proposal is, Andrew logs in, it's like, oh, my username is APBO, so in every single GET request I make, I am going to pass in a query parameter that gives the server the information of my username. Open hands if this is good, closed hands if this is bad. Cool, okay, I see some uncertain closed hands. Someone with a closed hand, why is this bad? Yes, Joshua. Exactly. You can literally just pass in someone else's username. This is in the URL bar. You can literally just type, like, edit it and change it. Okay. Modify proposal. This time we check the IP address of the request coming in. So if Andrew successfully logs in, then it logs, okay, this IP address is corresponding to Andrew, and he's logged in, and the server just holds on to that information. And then it can check the IP address of the other request coming in and see if it lines up with the IP address of someone who is logged in. Open hands if this works now, closed hands if it's still bad. Cool, someone with a closed hands. Want to venture a guess as to why this is bad? Yes. Huh?
Use a VPN.
Yes, exactly. So you can, there's something called IP spoofing where you can just fake your IP address. And yes, that would be bad. So this brings us to one of our most important principles that we're going to discuss when thinking about how to make our website secure, and that is you can never trust the client. So anything that comes in as part of information that the client sends to the server can be modified. So now where are we? earlier we talked about logging into with our website using Google or some other third-party authentication. And we wanted to know, how do we prove to our website that we successfully logged into Google? And then we talked about staying logged in. So we've logged into our website, and now we're making other requests. And we want to know, how do we prove to our website that we're logged in? So both of these are similar problems in that we have to prove that we're logged in somehow. And we have to do so without trusting the client, without determining our behavior based on information that the client gives us, because the client can change what information it gives us. And so now I'm going to hand it off to Andrew, and he's going to talk about a couple methods that we use to do these things.
Yeah, so this is a really important and interesting question, and there are kind of like two primary ways that we handle these in like modern applications. So the first way is with something called sessions, and the second way is with something called tokens. We'll start by talking a little bit about sessions, like what they are and how they work. So sort of the first step in like persisting any authentication is that the user has to first actually authenticate themselves. So in the context of Catbook, this looks like a login API endpoint where the user will essentially just pass in some credentials like username, password into the server. And so the first thing that happens once the server receives those credentials is they will take the credentials and they will verify the user. So they'll make sure that they indeed correspond to some valid user. And then they'll use those credentials to fetch this user's information from the database. And so what the server will then do with this user information once it has fetched it from the database is it will store it into something called a session. So you can think of a session as a global lookup table where the keys of the lookup table are these long random strings called session IDs. And the value in the lookup table is the corresponding user information. So just to reiterate one more time, once the server receives the credentials from the user, it will use those credentials to look up the user information from the database. And then the server will create this long session ID for the user, and it will store the session ID and user information into the global session object. So what will then happen after storing it into the session is the server will respond to the initial login request with the session ID that it had generated for the user. And when the client receives this response with this long session ID string, it will save it into something called a cookie. And essentially all a cookie allows the browser to do is it allows the browser to persist this data or session ID information in the browser. So what that means is that if the user were to refresh their page or maybe close the tab and reopen the tab, this cookie will still be in the browser. And so this is essentially the crux of how we're able to persist this authentication is because basically no matter what the user does besides actually deleting the cookie will essentially always be in the browser. And so whatever the user does, they'll have their authentication still be persisted. And so the way this works now is anytime the user makes some request, the request will be sent over with the cookie or the session ID as a header in the request. And so what the server can do is if it sees a request coming in that has a cookie or the session ID in the header of the request, it can check the cookie or session ID against the global session object, which remember the global session object is just a lookup table between session IDs and user information. And if it sees that the session ID exists, it can retrieve the user information of the client that sent the request, and then it can service the request appropriately. So for example, let's say the request is to retrieve a profile picture or something. If it sees that there's a session ID attached to the request, it can use the session ID to look up the user information, such as a profile picture, and then it can service the response properly. So one of the key things to essentially note why this is secure is because this the session IDs can only be generated by the session. So, or by the server. So if the server sees that a session ID is sent over with a request, it knows that this session ID must have been generated by the server, meaning that this user must have previously authenticated themselves. Otherwise, it would not be possible to have a session ID. Because the key is that these session ID strings are very long and essentially hard to spoof or basically impossible to spoof. So one of the key sort of aspects about sessions is that they are stored on the server. So you'll notice that when we were creating our session and storing like all the user information, all of this logic was being handled by the server. So in particular, like when we responded to the initial login request, we were just passing over a session ID to the client, and the client was not actually responsible for like managing their own user information. It was always just the server that was like managing the lookup between session IDs and like fetching the user information. And this sort of works well when you have like a smaller application with just like one client or like multiple clients going into one server. But let's say we wanted to scale our application and we wanted to like offload some like compute into like multiple different servers. Well, then you might imagine that the issue of storing like a global session object across like all of these servers becomes like a bit difficult. So like there are a few things that we can do to like solve this issue. Is like the first is to, like I said, like maintain a global session object across all these different servers. But of course, like synchronizing the session object across like every single server becomes like a bit complicated. Another thing you can do is you can store like a separate session object on different servers, and you can make sure that you're routing every client or like each individual client always to like the same individual server. This is also a viable option, but you can probably tell like that you have to do a bit more logic, and this will add like a lot of overhead to your requests. So this is kind of what motivates our like the next way that we can persist authentication, which is tokens, because tokens is sort of a way that mitigates this issue. So the first thing that we have to do for tokens is very similar to like the sessions. In order to persist our authentication, we need to actually authenticate ourselves. So the first step is that the user will submit a login form to some login endpoint. And this will include some credentials like username, password that they'll send to the server. Once the server receives these credentials, just like in sessions, the first thing that it will do is it has to validate the credentials to make sure that they actually do correspond to like a valid user. And then it will use these credentials to fetch information from a database. And so what the server will do here now is it will actually create something called a token. And in particular, like one specific type of token is a JSON web token. So essentially this JSON web token will encode a bunch of information about the user. And what it will do is it will send this entire JSON web token back to the client. So this is sort of like the major difference between sessions and tokens, is that now we're encoding the user information inside this like object, and we're sending all of it back to the client. So now the server is not maintaining like any global state. And what happens once the client receives the JSON web token is that it'll put it into local storage. So this is sort of like the same idea as like storing a cookie. Once the JSON web token is in local storage, it'll basically persist. So even if the user refreshes their page, like deletes their tab, reopens their tab, the JSON web token will like always be there. And so essentially what this allows for is that anytime the user wants to make a request, this like signed JSON web token will be sent in like the header of the request. And then what happens on the server when it receives requests is if it sees that an incoming request has this like JSON web token in the header, it can use the JSON web token to look up the user information that is encoded in the token. And again, like the reason why this is secure is because the server knows that only the server itself could have generated this JSON web token. These tokens are like very long and essentially impossible to like spoof. So because the server knows that like only a user who had previously received or who has possession of this token could have received it from the server, that means this like user must have previously authenticated themselves. So that's why this is like secure. And just one more time to sort of reiterate the difference between sessions and tokens. In sessions, when we like fetch the user information from the database, the server had stored the user information into a global session object that was living in the server. So remember, the global session object was just a lookup table between session IDs and user information. And this user information was never actually passed to the client. It was just stored on the server. Whereas in tokens, this user information was encoded into a JSON web token, and it was passed along to the client. And then every time the client wanted to make a request, it would have to pass it back to the server in order for the server to know like who the client actually is. So before we move on, does anyone have any questions about like sessions or tokens or anything that we've talked about so far? Okay, cool. So the next thing we're going to talk about is how we actually manage authentication in Capital. So as Abby mentioned earlier, the problem of storing passwords is like quite difficult. So we just let Google handle the authentication. So in particular, this means that we have to like separate our authentication server and our resource server. Where like resource server is just referring to like our localhost 3000, which is the backend that we've been like using this whole time. So for the initial login, what we have to do is we have to sign in with Google, which will make a request to the external like authentication server, and we'll get back like a JSON web token. And so in order to stay logged in, once we actually have like this like sign in thing with Google, is we manage our own like Express.js session inside of the backend. And so we'll take a look at what this looks like. So the first thing I'm going to do is I'm going to like propose like a Google sign-in flow that we can use. And you guys can try to see like whether or not you see anything like that's like vulnerable about this sign-in flow. So the first thing that we do as a client is, of course, we have to like validate our credentials, or like we have to log in. So the first thing that we're going to do is we send our credentials into the Google Authentication server. And the Google Authentication server, we just sort of black box it. We assume that it knows what it's doing, and it'll return either like a success, like you logged in correctly, or like your credentials were invalid. So let's say that the Google Authentication server says our credentials are valid and we get a success. Then as a client, once we receive that, we then tell the backend server that, hey, like I logged in as like this email or this user, and the backend server will use that email to fetch information from the database. So is this secure? Does anyone see like anywhere where this like workflow signing could possibly be vulnerable? Yes, in the back. Yeah, exactly. Nice. Essentially, like this connection between like the client and the server is still insecure because we could just lie about who we are. So to like illustrate that, like imagine that as we're like a malicious client and we enter like a wrong password into the Google Authentication server. Then we can just like lie to the server. Like there's nothing stopping us from still telling our backend server like, hey, we logged in as like this user. So the way that we solve this issue is, or I guess like this, before moving on, like this sort of goes back to the principle that Abby had mentioned earlier about like never being able to trust the client. In particular, like anytime the client does anything, we want to make sure that it's authenticated. So the way that we deal with this issue is with tokens. So in particular, like when we send our credentials into the Google Authentication server, the Google Authentication server will return a success token if we logged in correctly. So the success token is just like a JSON web token. And what we have to do now is once we receive this success token from the auth server, when we make a request to our backend, we actually have to send the token to our backend. And then what will happen is when the server receives the token, the first thing that it'll do is it'll use like a external like Google Auth library to verify whether the token is legit. And the reason why this is possible is because the token was issued by Google. So this like we can like ping this like Google Auth library. Essentially, it will know whether or not it will be able to like detect whether the token was actually like issued by like a Google Authentication server. And if it deems that the token is legit, then only then will the server like actually like use the information to like pull user information from the database. And let's say we have a hacker or a modified client now. Essentially, what will happen is we'll provide incorrect credentials to the Google Authentication server, and then the Google Authentication server will essentially like fail. So the hacker will not get a token. And the hacker can try to lie or like spoof a token and still tell the server like, hey, I logged in. But of course, like now once the server is validating the token, it'll easily be able to tell that like the token is like fake or not legit, and then nothing will happen. So, yeah.
Okay, cool. So just to reiterate where we are now, we talked about, we can never trust the client. Oh, question?
So in the previous slide, why wasn't it possible for like a website front end to send the username and password to the server, and then the server directly deals with the Google authentication server? That way there's no like in between where like change there.
I mean, that could totally work. It's just not the way that Google does it, and that's the main thing is just because then we would, as the like writers of Catbook, would have to create the logic to take in the username and password and securely send it over to the Google Authentication server. So this way is actually in some ways easier because Google manages like opening up that web page and having you type in your credentials and stuff like that. So yeah, in some ways it's actually simpler for us to implement.
Also, if you look into, this is sort of like the way we set this up is sort of akin to like the OAuth 2.0 like protocol. There's like a protocol that essentially deals with the idea of separating like the resource server and like the authentication server. So if we were to like call like the Google Auth server from our actual server, like Abby said, this is like definitely like a valid way to do it. It's just like we're just designing it so that it's like following this like protocol that like a lot of different websites use.
Okay, so where we are now, we talked about, okay, how do we not trust the client when we log in with a third-party authentication provider like Google, and when we make future requests and are logged in. And we talked about JSON web tokens, which use some fancy cryptography to make sure that it's impossible to fake these tokens. And then we talked about sessions, which basically store all of the information on the server so the user doesn't have access to it, and we just give them back like this long string session ID. And Catbook is actually going to use both of these. So when we first log into Catbook using Google, it's going to use a JSON web token. And then after we log in, then it'll use sessions to keep us logged in. And so Andrew's going to demo this next. And basically in the demo, we're looking from the client perspective. It's going to be in the browser. And so what we're going to see in this first part of the demo is we'll see when we make a request to the Google Auth server to log in, we get back this token as part of the response from the Google Auth server. And then we take that token and we send it as part of our login request to our Catbook backend server. So we'll see that receiving the token from Google and sending the token to Catbook.
Okay, so the first thing that I'm going to do is like open Catbook, and I'm going to open up the network tab in the console. And essentially this will allow us to see like all the requests that are happening. So the first thing I'm going to do is log in just to see like what requests are being sent as we log in. And you'll see that we have like these two requests here. So the first one is the login request. So this is just the request that's being pinged to like our own endpoint API login. But you'll also notice this like kind of weird like iframer PC request that's being sent. And if you look at the request URL, you'll see that the request is being sent to like Google OAuth. So this is actually the request that's being sent to like the external Google authentication server. And in particular, if we look at the response, we'll actually see what's happening when we receive like the success token. So we'll see like token type bearer just refers to like when we send this token to like our server, this is just like helping us like authenticate ourselves. And this like ID token field is actually where the like the JSON web token that we send to our own server is being stored. You'll also see that there's some like interesting metadata. So like you can tell like this token expires in like 35.99 seconds. So this token lasts for like 1 hour. And so something cool that we can do is JSON web tokens actually all sort of follow like the same like general format. So what we can do is we can actually like take this JSON web token and put it into like and like try to decode it. So there's like a interesting website called like jwt.io that will essentially take like any JSON web token and decode it for us. So I've already like pre-copied my web token. And what we can do is, and just to reiterate, this token is coming from like the console that I was just showing. It's just this like ID token field in response from the Google Auth server. So if I take this token and I paste it into jwt.io, we'll see that like some of the information that's being encoded in this token. So in particular, we see like three like parts of the token. There's like a header, a payload, which stores like the data, and also like a signature. So the first thing we can do is like look at the header. The header just stores some like meta information about the token. So there's this like, or like this specifics are not too important, but there's like the algorithm that's being used. So this is like the algorithm that's being used to encrypt the token. This is so like the server knows like when it receives the token, it knows like how to like try to like verify that it's correct using this algorithm. There's also like the type of token. So we've mainly only been talking about JSON web tokens, but of course there are like other types of tokens in the web. So the server needs to make sure to know that this is like a JSON web token. And one thing to note is that like this part of the token is actually like not secure at all. So this is something that's like very easily spoofable by a hacker. And this like looks like a very like complicated string, but actually this is just like base64 encoded. So what you can do is if you want to like decode a token yourself, or essentially like how this website even works, is that all it's doing is it's taking this string. And if you go into like any like base64 like translation thing, if you were to paste this part of the token into or like decoding it in base64, you'll see like the corresponding text is just like the JSON object that was corresponding to the header that was like being displayed in jwt.io. So this part of the token is not like what makes it secure. This is just some meta information that the server can use to like actually decode the token. And so like the next part of the token is the payload or like the actual data. So remember how when we were talking about like how tokens work, we said that like the server would encode the user information that it fetched from the database and it would send it to the client. And then the client was responsible for like keeping track of like its user data. So this part of the token or like the payload is that user data. So you can see like on the right, there's some like meta information about my account. So like my email, like my name and also that like my profile picture. So none of this is technically like private information. This is all like information that you can like know. So in particular, like this part of the token is also spoofable by hackers. So it also knows that like not all of these email, like not all of this like payload data is even used on the server. So sometimes you can even get away with like just saying like name, email, etc. So you don't need to know like all of these things. Again, this is just base64 encoded. So if I'm a hacker and I want to try to like recreate my token, I can also like recreate the payload too, because I might know like what like fields that the server is looking for. So I can just make my JSON object, I can base64 encode it, and then I'll also have this like second part of the token. So these like first two parts are not secure. The part that actually makes the token unique to me is the signature. So the reason why I can't show the signature is because obviously if I were to show my signature, then like anyone who's like malicious in the audience could like log in as me. So essentially the way this works is that the signature is generated by the Google Authentication server using like some like secret key that no one knows. So it uses like an encryption algorithm that basically relies on this like secret key. So if a hacker were to try to like reconstruct the signature, they would need to know the secret key. And because they don't know the secret key, it's a key that's like only the Google Authentication server knows, they won't be able to like recreate my signature. And the way that like the external Google Auth library.js like can validate this this signature is because it's also like a Google provided library. So that library like knows of like the possible keys that are being used by the Google Auth server. So that's how it can verify that the signature is like actually like correct. So yeah, this is sort of like a breakdown of how JSON Web Tokens actually look like. And so the next thing we can do is take a look at what's actually being sent in like the login endpoint. So in particular, like the payload of the login endpoint, or the payload just refers to like the body of the request. So Abby just lasered, this is the part of the diagram where we're actually sending the token to our like resource server or our like localhost 3000. So this token is like the exact same like JSON token that we just looked at. And what we can do is we can look at like the response of this login request. And we'll see that like there's like this set cookie header. So when we talked about like storing sessions, now that we've like authenticated ourselves, the next thing we have to do is like initiate a session on our backend server. So when we talked about storing sessions, the first thing that happens is the server will return or like respond to the initial login request with the session ID. And what the client does with that session ID is it will store it into a cookie. So essentially the way that that happens is inside of the response headers, we'll have like this like set cookie field, and this cookie will contain the session ID. So you'll see like connect.sid just stands for like session ID. And this is the cookie that's actually being stored in the browser. So the way that you can look at this cookie is by going to the application tab, and you'll see if you go to like cookies inside of storage and you go to localhost 5050, you'll see that there's this like cookie being stored here. And you might wonder, like, I made such a big point about like not being able to show the entire JSON web token. Like, how come I'm able to show like my entire session ID? Because in theory, like couldn't like malicious actor use the session ID to also log in as me? And the answer would be like, yes, they could, but only if they had access to my like localhost 3000 server that's like running on my laptop. So because like no one can access my like the server that's running on my laptop, then this is actually fine to show. But anyways, you'll see that like every time, like if I refresh the page, this cookie is still there, and also that I'm like logged in. If I were to like delete this cookie and refresh the page, then you'll see that like I'm automatically logged out. And so that essentially just shows that like anytime I'm sending a request, it's being like the cookie is being sent over as like part of the payload of the request, and that's what's actually like authenticating me. And then as soon as I like delete the cookie, then I'll no longer essentially like have a session, so I won't be like that authenticated.
Okay, any questions on what we've talked about so far? Yeah, look at that.
Like, set the session, I have to like show it, if no one has access to your local server, it's like a server that will define. Then like someone kind of like.
Yeah, so yes, if we had like a global server that I was like making requests to, then if I showed you my session ID and you made a cookie in your browser that was exactly equal to the session ID that I showed you, then yes, you would be able to log in as me. So
It's wait,
yeah, go ahead.
it is not secure in that like if someone can get access to your session ID, you're screwed. The thing that makes it secure is that it's impossible to like you can't really fake a session ID. So I can't be like, oh, I want to log in as Andrew, and without knowing the session ID, create like fool the server that I'm Andrew. So basically, what makes it secure in some sense is that I need the session ID, and these session IDs also don't last very long; they expire after a pretty short amount of time. So that's also why it's a little more secure. Cool. Any other questions? All right, solid. So next we are going to start implementing this in Catbook. If you were confused on any of the stuff that we just talked about, do not worry about it. It's a lot of new content. Feel free to go back and watch the lecture recording later. But for our workshop, we are going to be adding login, logout button to our homepage, and then we are going to connect our front end and back end. Then we're going to add a database schema so we can store information about users in our database, and then we'll add this to a my endpoint, which we'll talk about. So 4 steps in total. So if everyone could start getting set up for the workshop, and then maybe give me a thumbs up when you're done getting set up. So we need to fetch, which is downloads everything, the new updates from the remote repository, checking out to our branch, npm install, which remember, npm is just node package manager, so npm install downloads all of the packages like React and Express that we need in order to run our stuff. And then we'll start our localhost 3000 backend server, hot loader, and a separate terminal. We'll start our localhost 5050 front-end server. And then we'll open up navbar.js and just pause right there because I'm going to explain some stuff before we start coding. Thumbs up if you're ready to move on. Okay. Cool. So we have the step in the top right corner. So if you are stuck and you haven't gotten to check out to the next step, just a reminder that it'll just be W7 and then dash and then whatever's here to check out. Okay, so we're gonna look at what we've added to navbar.js since the last time we were doing that book. And we'll go through these things one by one. The first up, Google Client ID. What the heck is a Google Client ID? So before we were talking about client and server. Our client is our front end and our server is our back end. And essentially what makes this a client-server relationship is the server is just listening for requests, and then the client is the one that initiates requests. So the client sends requests, and then the server listens for requests, and when it receives one, it'll send back a response. And then there can also be, and there can be multiple clients all interacting with the same server. And so we also have this client-server request-response relationship going on between us, like our entire Catholic application, and then the Google Auth server. So there are multiple applications like us interacting with the Google Auth server, and the Google Auth server is just listening for requests. And when we send it a request, then it'll do its stuff and send back a response. So that's why we call our whole application Catholic a client of the Google Auth server. And so the client ID is basically just like we go to Google and we say, hey, we're going to be using your server because Google likes to know who's using them. And then we get this ID back and we use it anytime we call the Google Auth server. Okay. So next up, we have defined on lines 14 and 34 a Google login component and then this handle login function. So the Google login component here is just something that we imported. It's a React component that Google provides for us. And it has all of these parameters that we specify. And the one that I want to highlight is this on success. So can anyone tell me what you think is going on when we give handle login to this on success parameter? Anyone? Anyone? Yeah. Yes, exactly. So we're giving Google a reference to our handle login function, which we've defined. And then we're telling the Google login component, hey, as soon as they successfully log into Google, call our handle login function. Because the Google login component is the one that knows when we've successfully, like when we hit the login button and we successfully logged in. We're saying, okay, when the user has logged in, I want you to call this handle login function that I have written. And the handle login function, if you'll notice, takes in a parameter, and that parameter contains the response that we got back from the Google Authentication server, which will importantly contain our code. Okay, so we're going to give you guys around 4 minutes to attempt this. We need to add a logout button, and then we need to change our front end so that we display the logout button if we're logged in, and vice versa. And so the syntax for the Google logout button is here. So we're going to need to basically just copy that down and then define ourselves a handle logout function in navbar.js. And in order to tell whether we should be displaying the login or logout button, then we need to keep track of whether they're logged in or logged out in our React state. So I'll give you guys 4 minutes. Please, please, please hop on the help queue or ask someone around you if you are confused and don't know where to start. Can you raise your hand if you'd like more time for this? Okay, cool. We will give you guys a little bit more time. If you'd like a hint for conditional rendering, we can have some kind of condition, so some kind of Boolean condition. So that could be like a Boolean variable or something else. And then question mark, something to render if it's true, colon, something to render if it's false. All right. We are going to start transitioning into live coding. Don't worry if you didn't get it all down, but feel free to like put your computer's screens down if you want. No need to worry about copying all this down, but definitely just follow along as Andrew explains.
Yeah, so the first thing we can do is sort of like the hint suggested is we can make a state for whether or not we're logged in. So we should import use state from React. And remember like the syntax for making a state is like we have a const, the name of our state, call logged in, and also like a setter. And then we use the use state hook to declare like an initial value. So by default, we don't want to be logged in, so we can declare the initial value to be false. And then inside of handle login, all we do to modify the state is that we set logged in to be true, assuming that we've already logged in. And then we also want to make another function for handling logging out. So to log out, we can just like console log like logged out successfully. And then we can also set the logged in state to be false. And then, so like Abby suggested, for rendering whether or not we're doing like a login or like a Google login component or a Google log out component, we can use like a ternary. So we have to encompass it in braces, and then we essentially want to see whether or not we're logged in. If we are logged in, then we want to display the Google log out component. So we'll just copy the syntax for now, and that this will be like a Google log out component. Otherwise, we want to render a Google login component. So again, just to reiterate this, we're checking whether or not we're logged in. And if we are logged in, then we're rendering a Google log out component. Otherwise, we're rendering a Google login component. And there are a few like different props for the Google logout component. So client ID stays the same. We want the button text to show log out because this is a log out button. And it's called like on log out success instead of on success. And the function that we're passing into this on log out success is the handle logout function that we just made. And then it looks like the other two stay the same.
Any questions on this code before I test it?
Okay. So now if we refresh our page, let's try logging in. Cool. So we see that there's like a logout button now. So the logout button is rendering. And also when we do log out, we expect to see like a console log. Because inside of our handle logout function, we're console logging. So nice. It looks like the button changed into a login button. So the state updated properly, and also we get our console log.
All right. Next up in order to, oh yes, feel free to reset hard and then check out to W7 step 1 if you weren't able to get all that code down. Okay. And then for this next step, this is pretty straightforward. All we need to do is make a database schema so we can store information about our users in our database. And the information that we want to store about users right now is just the name and the Google ID. But later we might want to add other information that's relevant to that. So I'm going to give you 2 minutes to work on this. Oh yeah, and oh, sorry, I thought you were asking something. If you missed the commands to check out, it's just git reset dash hard, and then git checkout W7 dash step 1, and then step is in the corner. All right, thumbs up if you're ready to move on. Okay, I'll give a little more. Okay, since this is pretty straightforward, I think we're not going to live code it, but feel free to just check out to the next step. And all that we would do is just create a new file, user.js, and then copy and paste in from Story or one of our other database schemas. It looks exactly the same. So we just create a new monolith schema that contains these fields, and they're both type string. And then the last line is just exporting this model so that in other files, when we want to use it, we can import it. Any questions on the code on this slide? All right, cool. So we're going to ask you guys to check out to step 2. And then as soon as you do, you'll notice some new files appear. And so we're going to discuss these files and what they do in a lot more detail after this step. But for now, we're just going to say briefly that we have this file called auth.js, and this provides a few different functions. In auth.js, we have defined a login function, a logout function, and then later we'll talk about rec.user. But auth.js is just a file that WebLab staff wrote for you. And then in api.js, can you show how we import it? Yes, okay. Here on line 15 in api.js, we're requiring, which is basically the same as importing everything from our auth file. So all that does is it's basically like we defined these login and logout functions for you in api.js. You can use them just like we define them in the file. But we define them, we put them in a separate file, auth.js, just to keep it clean. Okay. And then you'll also notice some changes to server.js. We're not going to go into much detail on this slide, but basically the new thing that we added is just setting up express sessions. So this will be what we use to keep you logged into Kappa. And we'll talk more about this in a bit as well. But for now, we're going to have you guys connect the front end to the back end. So you can just copy and paste down these lines in API.js. And all that does is create an API login and logout endpoints. So saying, hey router, I need you to listen for HTTP post request to /login. And when you receive one, I need you to call the function auth.login. So that's the login function that we defined in auth.js. And then same thing for logout. We say, hey router, I need you to listen to a post request, listen for a post request to /logout. If you get it, call this logout function for me. And then what we want to do next is we want to add the logic to navbar.js to actually send those post requests to log in and log out. Any questions on what we are asking you guys to do here? Okay, cool. So we're going to give you guys a few minutes to do that, and please hop on the help queue if you don't know where to start or are confused.
It's like about the new files. Maybe dot login. Maybe, yeah.
I sense some general confusion in the room. I'm not sure if that's accurate, but just in case people around you are stuck, can you take like 30 seconds and talk to the person next to you about what we're doing, about like what's going on in this slide and what we're trying to do in this step? And if as you're talking about it, you're realizing like, oh, okay, we're really confused about this or that, then after we come back together, we can ask questions so that hopefully everyone can get to a better understanding of what's going on. So take 30 seconds and talk to the person next to you about what we're doing here. All right, I'm gonna pull us back together, and from your conversations, does anyone have questions or things that you were both confused about? Right, can you, yes. How do we input this? Do you know where which file the like example would be for giving a post request? Wait, I probably know the syntax. So in the front end, we've used post requests for when we're posting stories and posting comments. And in there, the syntax for making an HTTP request, which is basically just calling this function that Andrew has explained. The syntax for calling that function would be post. And then the first parameter is the endpoint. So we would do like, in the case of a story, we would do /story. So the API endpoint that we want to go to. And then the next parameter is what we want to pass in as part of the post request. So we would have this is if we don't want to pass in anything, just like empty, but normally we would want to pass in a JSON object that would have certain parameters. So for example, in our story, we would post like content, colon, whatever, and then whatever other fields we have there. And so this is example syntax for creating a post request. Does that help you something? Okay, cool. Any other questions? All right, cool. Why don't we transition to live coding, and feel free to raise your hand and interrupt us if you're stuck on anything.
Okay. Oops. Okay, so the first thing that we have to do is we have to add these endpoints into API.js. So we can just like copy directly what it says on the slide. And once we've defined these endpoints in our backend, we can go to navbar.js to actually like to call these endpoints when we're like logging in and logging out. So inside of handle login, we're instructed to make a post request to the login endpoint where the parameters is just the token or like the Google Auth token. So we can do this by like using this post function, API login, and then the parameters. We're given that the Google Auth token is passed to handle login as res.tokenobj.id token. And then this returns a user. We can just like console log for now. And for handle logout, we want to do the same thing. Except this like logout function does not take any parameters because we don't have to like verify ourselves to log out. So we can, I think that's it.
Wait, can you move that code up for a second?
Sure.
Any questions on this code? Remember that, so we're in the front end on our navbar. And so that's how this posts thing is the syntax for how we send an HTTP post request to this endpoint with this, like as the body of the post request with the token. And then the .then is to say when we receive back the HTTP response from the server, then we're just gonna log it. Thumbs up if we're good to move on. Oh yes, question.
Yeah, that's a good point. It's a good catch. Yeah.
Thumbs up if we're good to move on. Okay, cool.
Okay, so I think that's pretty much it for this step. So we can try like testing to see when we log in, we should be printing the user. Okay, and it's not doing that, so wait. Okay. So this essentially means that auth.login is like working correctly because we're getting the user back. And if we were to log out, then we still have like logged out successfully.
All right, cool. So now this step was really big and there was a lot going on in this step. So we're going to just take a little bit of time to talk about what's going on here. This is the commands to check out to the next step if you want to. I highly recommend everyone check this out and then have that code for this step on your computers, and we're going to be poking around and looking and figuring out what's going on. So if you could check out W7-step3-V2. And then give me a thumbs up when you're all set. Cool, all right, I'm going to move on then, but we have it, the command in the corner. All right, so I have a gigantic diagram, which is exactly the same as the diagram that we saw earlier, where it was just like the overall, how we log in with Google diagram. But this time, we're getting a little more fine-grained and seeing what's going on in our code. So we still have the thing where we, actually, so in our client, which we're going to be focusing on for now, all of our work is being done in the navbar.js file. And inside our navbar.js file, if you look online, I believe it was 34 or something, we can see our login button. Oh wait, sorry, not 34 anymore. Can you go to the Google login component? Cool, okay. So we have this Google login component here. And this is defined by Google in the library, but basically it knows that when you click on it, it's going to open up a window, have them log in with Google, and see if their login is correct. So this Google login component handles calling the Google Auth server and having you log in. So when we get back a response with a token, then the Google login component is the one who gets that response. But what the Google login component does is it calls our handle login function. Because, wait, can we go back to the Google login component? Okay, cool. Because we handed our handle login function as a callback function and said, okay, when they successfully log in, call our handle login function. Okay, now we can go to the login. Okay. And so what we do in our handle login function is we take a response. That response contains the token that we got back from the Google Auth server. So the Auth server, when we successfully log in, it gives the token to the Google login component, and that Google login component calls our handle login function and passes that token along. Okay, and then once we hit the handle login function, then we want to send that token to our backend. So we want to make a post request to our Catholic backend that contains that token that we got back. And so that's what we're doing on line 25 here. We're sending a post request to our Catholic backend with the token that we got from the Google Auth code, this response object thing. So what happens when the backend receives that post request? The answer to that is in API.js. So we see that our router is listening for post requests to the /login endpoint. And when we get a post request to the /login endpoint, we're going to call the function auth.login. And so that function is defined in auth.js for you. So on the diagram here, when we get the post request, it will call the function login in auth.js. So let's see what's going on in there. This is code that WebLab staff has written for you. In auth.js, the first thing that we're going to do is we're going to call this verify function with the token that we got in the response. And this token is calling like client, which is the Google client, .verify.id token. You do not need to worry about all the syntax for this, but basically in the login function, we're calling verify, and that's just going to check if this token is valid within the Google Auth library. So that's this part where we ask the Google Auth library if this token is legit, and they're like, yeah, okay, we're done. And then once we verify that the token is legit, then we're going to call get or create user, which happens here. And that is going to basically just create a new user in our database or get the information from our database. So there's our Catholic database. And then the other thing that it's going to do, which is very important, is it's going to save the user in the session. So on line 40, we see rec.session.user equals user. And rec.session is something that Express does for us, where basically Express will make sure that rec.session is the same, it still contains all the information that it had before, even if the user refreshes the page. And we'll talk about what that is, what that's doing, a little bit more detail in a bit. But just know that we're setting rec.session.user to be the information about the user from the database if once we successfully log in. Okay. So now let's talk about what happens when we log out. So it's the same thing where we're communicating between our client and our backend, but this time it's simpler because we don't have to talk to the Google Auth server, this library, or our database. All we need to do is in navbar.js, we have this Google logout component. And the Google logout component knows when we successfully log out. And so we tell the Google logout component, okay, when you hit the logout button, I want you to do this. I want you to call my function handle logout. Let's see what's there. Here, we're just gonna console log, change our React state so that we can render the login button. And then we're gonna make a post request to /API/logout. And that's this part of the diagram here. So we click the Google login component, it calls our function, which makes a post request to our backend. And when our backend receives that post request, let's check API.js. Similarly to before, we're gonna call the function auth.logout. So that function is defined in auth.js. And all that this is going to do, not going to talk about database, any of that. All it's going to do is it's going to set rec.session.user to null. So we're going to clear out the information in the session about who's logged in. And then we're just going to send back. Okay. Any questions on that so far? What's going on in the code? Okay, cool. So main takeaway from all of this is that when they log in, we populate rec.session.user with the user's information. And when they log out, we set rec.session.user to be null. And so then we have rec.session.user, which allows us to tell whether someone's logged in. And in the Catholic skeleton, rec.session.user is equivalent to rec.user. As to where rec.user came from, if you want to just know about it for like the purposes of coding, feel free to just be like, okay, we'll just use rec.user and not worry about all of that and not worry about how it came to be. But if you're curious about how rec.user actually gets populated or why in our API endpoints we can use rec.user to get information about who's logged in, the basic idea is this. So we remember that we have the client, the server, the client makes a request, the server sends a response. Actually, it's a little bit more complicated than this. With Express, it looks a little something like this. So the request comes in, like we had on the previous slide. And then what Express does is it creates these request and response objects. So it almost wraps the incoming request into these JavaScript objects which has certain methods that we can use. And then there's this idea of middleware. That is, we take our request and inside our server, so like all of this gray stuff, or like actually all of this stuff happens inside the server. So this is all part of the server. What happens is we use something called app.use, which you can see in server.js if you look at app.use and then a bunch of different things. But we basically take these request and response objects and send them through, like, it's almost like an assembly line. Each thing is doing a different thing to our request and response until we're ready to send the response back. So the first thing that happens is Express does some stuff for us. So not only does Express wrap our incoming request into this object, but it also checks our session, because in Express we set up these sessions, and so Express will populate rec.session with whatever information that we had stored in there before. So if the user refreshed the page, Express will be like, oh, before we had rec.session.user populated like this, so we'll attach it to rec.session. And so then this request and response objects, they get passed along from one thing in our like little assembly line to the next. And so since Express has already populated rec.session with whatever was there before, then we can use it in the rest of our sequence of things that happen in our server. And so there's a few other things that happen, like we parse the JSON body. And then the other thing is that we populate rec.user. So we take rec.session.user and just say rec.user equals rec.session.user. And you can see that in server.js if you're curious. And since these request and response objects just get passed along, then things that are later in our sequence of events can access the things that we populated earlier. So rec.user happened before we send these request and response objects to our API endpoint. And so the code in our API endpoint, like /stories, can access rec.user and rec.session.user, etc. And then the API endpoint is the one that sends back the final response to the client. Okay, that was a lot of concepts. Any questions on that? Or would anyone like me to re-explain? Raise your hand if you would. Okay. Cool. I will have to move on then. So basically, the idea is that Express manages our sessions for us. So we can access user information in rec.user, and that will stay even if they refresh the page or something like Okay,
Okay, so next, like, does it actually work? So you'll notice if we go to our browser right now and we log in, one of the things that actually happens, like, let's say we try refreshing the page, is that you'll notice that this like Google login component actually changes to like login. So essentially what's happening is that right now our like backend knows that we're logged in, but when we refresh the front end, it doesn't remember that. So what we have to do now is we have to implement some way for the front end to like remember that we're logged in. So the way that we're going to do that is by essentially every time we load the page, what we want to do is we want to make a query to the backend that asks, are we currently logged in?
so basically with the sessions, our backend knows that we're still logged in, but we need to make sure that our front end also reflects that.
So I think for the sake of time, we're just gonna like quickly show like how we would implement this. So the first step is we want to actually make our endpoints. So we can go to api.js. We'll see on line 56 that we have like a to-do to implement a new endpoint called like who am I? And this will essentially return the user object if it exists. Otherwise, we will return an empty object. And like the purpose of this endpoint is just so that the front end can like hit this endpoint whenever the page loads, so it can see like whether or not we're actually logged in. So we can do router.get who am I? And then we just have to check. Remember, as Abby mentioned, this rec.user object is something that we can just use because it's populated with like the middleware. And if it does exist, then we can just send the user. This is the, yeah. And then, so if rec.user exists, then we can just send it, because remember that rec.user holds like the user object. Otherwise, we can just send like an empty user object. And then inside of navbar.js, or before I move on, does this like little bit of code make sense to everyone? Okay, cool. So I'll navigate to now navbar.js, which is like in our front end. And essentially all we want to do is every time we reload the page, we want to make a query to this endpoint to see whether or not we're already logged in. So we can do this using the use effect hook. So remember that the syntax for use effect, it's like it takes in a callback function. And because we want this use effect to run every time we like reload the page, we can pass in an empty dependency array, which just says run this code whenever the component mounts. And then the code that we want to run is we just want to make a GET request to this like new endpoint that we just made. And this GET request returns the user, and then we can check. Remember that if the user does not exist, it'll just be like an empty like JSON object. So we can check any of the to see if any of the fields exist. For example, like user._ID. And if this like key in the JSON object does exist, that means that the user object also exists, which means we must be logged in. So we can just set logged in to be true. And by default, the logged in state is like false. So we don't have to like explicitly set it to be false again.
Andrew, could you pull up API.js on one side and navbar on the other, maybe?
Sure.
All right. So just to review what we did here is we want every time we reload the front end, we want to check if we're logged in. The back end knows, can keep track of our sessions and know if we stayed logged in, but the front end doesn't. And so we have this use effect which says, okay, as soon as we load the page, we want to make an API call to /API/whoami. And then what happens when we make that call is this in api.js, where we check if rec.user is populated, which means that there's a user in this current session. And if it is, we send that information about the user. And that information will contain _ID for the user. It might contain their Google ID or their name or something like that. But if there's no one logged into this session, then we're going to send back an empty JSON object. And then the dot then here on the nav bar is saying, okay, as soon as we get back the response that we sent from our API here, as soon as we get back the response, then we're going to take that and we're going to check if it has the ID field. That's just one of the fields that, and if it has the ID field, we know that it wasn't this empty JSON object that we set here in line 62. And so if it has it, then we know that we're logged in. So back in history, the front end of the logged in, and we can set our state accordingly.
So yeah. Is there a question?
Yes. So rec.user, question was, where does rec.user come from in the API? And basically in our Express app, we have these, as soon as a request comes in to our server, Express sort of wraps it in these request and response objects. And every single like middleware thing that we use, for example, the API endpoint takes in the request and response objects as parameters. And so it's like we're passing these request and response objects through this whole middleware stack, as they call it, of different things that we want to do with them. And so the first thing that will happen is Express will populate rec.session with whatever was in rec.session before. So if they refresh the page, then Express will say, okay, rec.session should be what it was before, which if we set rec.session.user before to be the information about the user because they logged in, then rec.session.user Express will repopulate that. So then everything later on in the stack has access to rec.session.user. And that's how we pass information from like earlier in the stack to later in the stack, which is we attach it to the request object. So that's what we keep that. Yeah. And so then later on in the stack, we basically populate rec.user with what rec.session.user was. So then that is attached to the request object. And then since the API endpoint is later in the stack, then the API endpoint has access to rec.user. Does that make sense? Okay, cool.
So if you want to see like the completed code, you can check out w7-complete-v2, and you should be able to see like all the endpoints set up, and also that if you like refresh your page, that you should stay like logged in.
Cool. Okay. Thank you all for bearing with us. Authentication is a gigantic topic, and we have to go very fast. But if you're confused on anything, please bring your questions to, I mean, you can ask us now, we'll learn it soon, or come after lecture or come to office hours. We'd be more than happy to help you grab the brains around this. And now I think Mark potentially